So 2.6 day 2, we get to learn about the but on step 6C. Okay? 6C said if the degree of the numerator was greater than the degree of the denominator, there was no horizontal asymptote. But if the degree is greater by exactly 1, then the degree, the denominator, the graph of the function has a slant asymptote, and it is found using long division. Okay? So if the degree of the numerator is greater than the degree of the denominator, you say no horizontal asymptote, because you put HA on your thing and say none. Okay? But if it's greater by exactly 1, there's a what? Slant. And how do I find it? Long division. The example down here is just to show you when I divide x squared minus x by x plus 1, I get x plus 2, and then I have a remainder. I do not care about the remainder. Don't care. What kind of an equation is this right here? It's a linear equation with a y-intercept of -2 and a slope of what? 1. Should you be able to sketch that on your graph? Pretty easily. So when you do the long division to find the slant, do I care about the remainder?
It would appear not.
No. When I do it, I don't even finish. Once I get my linear, I stop. I don't even finish it out. There's no point. Make sense? So that's the only notes we're adding. Now, guess what we're going to do?
An example.
Okay.
We're going to do the Macarena.
Ha. Ha. So,
Who knows?
Brad, are you good?
No.
Okay. Let me know when you're.
It was fine.
Elena? You too? Okay, so this was that little space I told you leave under 6, right?
I need to write down
Just all you care about is the equation. You don't care about the remainder.
I'm good.
You're good? Kelly, you good?
Yeah.
Okay.
What, Taylor?
Nothing.
Yeah.
Oh, stop. So that's just a picture of that. I forgot I had it added in there. I have a y-intercept of -2 and a slope of 1. So see this graph. The graph comes down and it just goes along that slant asymptote. Everything else is the same. Slant is like a horizontal. It only affects to -infinity and positive infinity. Does it affect anything in the middle if there's middle chunks? No. Okay. So we are going to sketch f of x equals x squared minus x over x plus 1. While you're writing your equation, I'm giving myself a coordinate plane, and that's not straight.
how do you try and get it so straight?
They have a function to draw a line, just a line. It's still not straight, but it's better than what I can draw, right? Okay, you guys got it written down?
Yeah,
Okay, so what is the first thing that I do?
domain.
Nope. Simplify, thank you. So the numerator is x minus 1. And the denominator is x plus 1.
Yes.
Does it reduce?
No.
No. Now the next thing I do is domain. So put your domain.
X has the edge. X cannot equal -1.
Yes, you did do it right.
Genius.
Oh, there for a second before you put the y on squiggly, I thought you were putting -1 squared.
Oh. Okay, so then x-intercept is what we've been doing next, yes?
Yeah.
So x-intercept. How do I find x-intercepts, Evan?
Like 0 and for the y's.
0 and for y, so I set the what equal to 0?
Equation. You set the numerator.
I set the numerator. I am actually setting the equation. You are not wrong, Evan. But when I multiply over the denominator, every time it's going to be 0, correct? So there's no point having to do that step, but you're not incorrect. So I have x and x minus 1 equals 0. And that's after I simplify, correct?
Yeah.
So then I get x equals 0 and 1. So my x-intercepts are 0, 0, and 1, 0. X-intercepts need to be written as points. Now, since I got 0, 0 as one of my x-intercepts, what should I know my y-intercept has to be?
0, 0.
0, 0. So if it doesn't come out, is that a check that something went wrong?
Yeah.
Okay, Ethan, how do I find y-intercepts?
Plug in zeros for x.
Plug in zeros for x. You can do it in the reduced or the non-reduced. I usually go back to the original. So 0 minus 0 over 0 plus 1 is 0. So I get what? 0, 0. So we're good there, yes?
Wait, yeah.
No. Never mind.
Are you good?
No. but
0
let's go
plus
on.
Okay, 0 on the numerator and 0 plus 1 is 1. What's 0 over 1? 0. If I have no candy, Evan, how much does everybody get?
Enough.
God dang it.
Okay, so x-intercepts, y-intercepts, what's next? Vertical asymptotes. Now, guys, are these like, you have to do them in this order?
No.
No, but I'm always going to do them in this order. I would suggest you find an order you want to do it and do it, because then you don't forget anything, correct?
Yes, ma'am.
Okay, so vertical asymptotes. Austin, how do I find vertical asymptotes? Look at your sheet.
Okay.
No, look at your sheet. It tells you on there.
Denominator. Set the denominator.
Hey, I don't have that.
Put a 0. Or a 0.
Set the denominator equal to 0. You didn't find it in your
No, I
notes?
knew that. Oh my god.
Wow, you're so cool.
I am.
Okay, so when you set your denominator equal to 0, so I get x plus 1 equals 0, and so x equals what? -1. Horizontal asymptote. Isaiah, how do I find a horizontal asymptote?
You do the degrees
Degrees of what?
of the denominator. Well,
Numerator compared to the denominator. Numerator always comes first, right? What's the degree of the numerator?
2.
2. What is the degree of the denominator?
1.
1. So 2 is greater than 1, so that means there is
No.
none. But
Long division.
is it 1 bigger?
yes.
Yes. So I need to do long division. So there is a slant. Okay. So on every problem, I have to see a horizontal asymptote. Tell me there is one or isn't one. Got it? But are you going to do a slant on every problem? No, only if it's one larger. So I take x plus 1, and I still have to follow all my rules for long division, so filling in gaps or anything that happened is to come along. Okay? So what do I multiply x by to get x squared? X. Now, I'm going to tell you this, guys. It may have a coefficient, but will it ever be more than x to the first? No, that's why it's only 1 degree difference. Okay, so then I'm going to multiply everything by negative x. So I get negative x squared minus x, and I get, oh, no, I don't. No, I don't.
Oh, you good.
I get negative 2x.
Yeah.
Okay, plus 0. So what do I multiply x by to get negative 2x?
2.
Negative 2. And guess what? I'm not even going to do any more. I'm stopping.
You got x minus 2.
Because I have y equals what? X minus 2. What?
Wouldn't it be negative x minus 2? Because you multiplied by a negative.
No, I had to get positive. This negative was so I could subtract it.
Then the remainder.
X times x gave me x squared. The negative was because I was subtracting it.
Yeah, but you have down there that you're multiplying it by a negative.
Yes, because you really multiply it by x, and then you have to multiply everything by a negative 1 to subtract. So I just did it together. I want what I have to at the top.
We should do that in a thing.
Yes, we will. Okay, so now we have all our asymptotes, all our intercepts. Are we ready to put that much on our graph?
Yeah.
Graph, not graphed. Okay, we're ready to put that much on our graph?
So if there's a remainder, what does it do?
Nothing. I don't care. I didn't even do anything with it. I got my linear equation, I stop. Because I don't do anything with the other. Okay, so x-intercept at 0, 0. Oops, I thought I put that at red. At 0, 0. And at 1, 0. And then I have a y-intercept at 0, 0. I have a vertical asymptote
At negative 1.
at -1. Horizontal asymptote I don't have, but I have a slant that goes through -2, yes? And has a slope of 1, 1, 1. I find my x and y intercept. That's what I like to do. Because if I can connect my x and y intercept, I don't have to count a slope, do I? And since I don't have graph paper, is it easier just to connect an x and y intercept?
Yeah.
Yes. So I have a y-intercept. How would I find the x-intercept of this equation? Put a 0 in for what? For y. So what is my x-intercept? 2. So 2. And now I just connect those two.
He disconnected.
Wait, wouldn't it be positive?
Yeah?
That's why.
That's why it's through positive. Okay, so now I have to do my interval analysis. Now, I'm going to draw this little dude on here, and then I'm going to not leave him there, but I'm going to draw him there just so you can see him. You need to think about this little person walking down the street, okay? As it walks this way down the street is the x-axis. Got me?
Yeah.
The only thing that gets in its way is fences and manholes. Okay? So vertical asymptotes are fences. Manholes are x-intercepts.
Okie dokie.
So, what is the first obstacle that he approaches?
The fence.
A fence. So I have my int a, yes?
Yeah.
So negative infinity to what?
-1.
-1. And leave yourself some room, guys. We're going to have to do some math, right?
Ew.
Okay, so -1, I leave -1. What's my next problem? 0. I leave 0. What's my next problem? 1. And I leave 1?
2.
No,
What?
It's not a verb.
it's not a vertical asymptote. It's a fence laying on its side.
1 to infinity.
So 1 to
Positive.
positive infinity. The only thing that make these are x-ints and VAs.
Yeah.
So this is how you know if you have enough. How many x-intercepts do I have?
4. Or 2.
2. How many vertical asymptotes do I have?
1.
1. So if I have a piece of string and I cut it 3 times, how many pieces do I have?
4.
4.
Yeah.
Do I have 4 intervals?
Yes.
Yes.
Who said?
So you always have
I did. I didn't think of
You always have one more interval than you do x-intercept and vertical asymptote combined.
Alright.
And I do always check. Because if we ended up with 6, did I know I did something wrong?
Yeah.
Yeah, I counted that horizontal asymptote and it set me off. Okay, so I need a number that is between negative infinity and negative 1.
-2.
Negative 2. Okay, so what I'm doing, guys, is I'm plugging negative 2 into this equation right here. I don't care if I get negative 18. I want to know if it's positive or negative every time I plug it in for the x. That's all I want to know. So when I put negative 2 in for x, do I get a positive or negative? Negative. When I put negative 2 in the x minus 1, do I get a positive or a negative? I get x minus 1. So negative 2 minus 1 would be a negative. That's the division bar. When I plug negative 2 plus 1, do I have positive or negative? Negative. So I have how many negatives? 3. So what's my rule on that? It's going to be negative. So now I need a number between negative 1 and 0. Negative a half. Again, I don't care what the number is going to be. This is our number sense. I don't have to get common denominators. I just have to know if 1 is bigger or smaller than negative 1/2, correct?
Yeah.
So when I plug in negative 1/2 into x, what do I get? Negative. When I plug negative 1/2 into x minus 1, I get negative. When I put negative 1/2 into x plus 1, I get a positive. So the whole thing is going to be a what? Positive. Because I have an even number of negatives, correct?
Yes.
Okay, so far I'm negative. Oh, we're going to talk about that again. Never mind. Okay, between 0 and 1.
1/2.
1/2. Again, try it on your own. See what you get.
Okay, so I'm confused. How do you know what you meant where to plug it into?
You're plugging it into this right here for x. You're putting 1/2 in for all those x's.
Oh.
And just do it in pieces.
Hey, Miss Mac, guess what?
What?
You're right.
Okay, thumbs up. Yes, I got it. Or no, I did not get it. Callie? Did you get it or not get it? The right answer. Okay. So next one. Between 1 and positive infinity.
Oh, yeah.
Who?
Okay.
Oh,
2?
wait.
I put 5.
No, no, I didn't. I thought it was positive because there's positive.
But you have only one negative, so it's negative, correct?
Okay.
So this is my work, guys. This is what I want to see. Does it help you do the problem?
No. Yes.
It should. Please don't pop your gun.
Kind of. 1 to positive infinity.
Okay. So did you guys get positive?
Wait, what number did?
Any number you want, Isaiah.
Any number bigger than 1.
Okay.
Ow.
Okay. So I'm going to erase my little guy because he gave us our intervals already. Okay. Bye, guy.
Bye, Bob.
Okay, so we need where this graph is going to be positive or negative. Okay, so the first chunk, it says it's going to be negative. Right here is negative, but can I be right here?
No.
Because if I was here, I would have to go up through the x-axis, and that wouldn't work, would it?
No.
So I'm not going to be up there. I'm going to be way down where?
There.
There. Okay, so the next chunk, it says it's positive, so it's plus, right?
Yay.
And then it's going to be negative right in between these two. And then it's going to do what again? Be positive. And why did I know to put it above the slant and not below the slant?
Because that's where your intercepts are.
Yeah, that's where my intercepts are. There's no x-intercepts down here. I can't have a piece of the graph there, can I?
No.
Okay, so now I just make my curves. If I know I have to be between these two asymptotes, then I do what?
You make it between the two
Okay, do I know how far up it goes into that
No.
V? No. Do I care?
No,
No. This is just a sketch.
I wish you did.
That's for calculus to figure out. Okay? So then now on the next piece, we start positive, go through the x-intercept, come down and go back through the x-intercept and go towards the slant asymptote, don't I?
Yes, ma'am.
Yes, ma'am, are we?
So, just because I added the slant asymptote in here, did it really change my process any? No,
That made it harder.
Easier.
not really. I don't think it made it harder.
It made it.
Okay,
Longer.
so do we want to do another one together or do you want to just get on going on your own?
Get going.
Let us go.
Get going. Okay,
Can I use the
remember, yes, you may. Remember, do I care about my remainder?
No.
No, I do not care about my remainder.